For our secure software development assignment, we have used our third year final project to identify the vulnerabilities. So our application is Novice Coder application, which is a web-based learning management system built with JavaScript technologies. In there, we have identified several vulnerabilities that we have done using SonarQube and SAP, the black box and white box testing. And after that, we have fixed the vulnerabilities using several methods. So our first identified vulnerability is broken authentication and session management. In there, we have added the Auth0 integration, which is we have created an application through the Auth0 platform. So in here, we have added two platforms like Novice Coder app and Novice Coder API for the back end and the front end. In there, we have provided the URLs for the callbacks, and after that, install the Auth0 dependency in the front end application like this. And next, configure the front end application with Auth0 application details like this. Finally, we have created the users using Auth0 application and given the user base credentials for the users. This is the front-end application that we have created, and this is the back-end application that we have created. So next identified vulnerability is insufficient access control. For that, we have given the role-based access control through the Auth0 integration. In here, we have created the users like admin, student, and lecturer for the learning management system. And in here, we have created the roles. According to the roles, we have managed the application. And after that, in the APIs, in the permissions, we have added all the permissions: create course, delete course, create lecturer. Likewise, we have created all the permissions, and after that, through the users, we have added those permissions for the relevant users. Like that way, we have provided the role-based access control. In the Auth0 dependency, we have added in the Node.js API application like this. And configure the application with Auth0 application details. And after that, that I have said, list of permissions we have added like this, and the roles. Like this, we have given all the permissions, and as well as configure the API application endpoints with the created permissions. In the API application, we have added the role-based access control settings enabled.
Okay. I will present two significant security vulnerabilities which I have identified in the Novice Code application under the section Vulnerability Identification and Analysis section. Insecure dependencies, security, critical severity. The first vulnerability pertains to insecure dependencies with critical severity. During our security assessments, I have identified multiple outdated NPM packages in both the front-end and back-end code bases that contain known security vulnerabilities. Automated tools like NPM Audit help me to detect these vulnerabilities. The presence of vulnerability package poses the high risk because attackers can exploit them to inject malicious code, cause data breaches, and disrupt services. For instance, packages like Node Fetch and NTH-check were flagged as severity due to unsafe header forwarding in an insufficient regular expression complexity. The risk was considered high because these vulnerabilities are easily detected by the automated scanners. To fix this, ran npm audit fix command to which update the replace vulnerability packages, effectively reducing critical issues to zero. This process highlights the importance of the consistency dependency management for the maintained application. The second vulnerability involved token forgery or invalid tokens. In the context of JWT-based authentication, JWT tokens are widely used to validate user identity and permission by relying on the cryptographic signatures, typically RS-256. However, I have found the application originally lacked proper validation of critical token parameters such as signature, issuer, audience, and expiration. These improper validations leave the system exposed to attackers who could fork tokens with arbitrary claims and bypass authentication or authorization checks. To address this, I have implemented true JWT signature validation using Express JWT RSA libraries. These tools verify the token RS-256 signature, confirm the token issuer and audience, and ensure tokens have not expired. This validation prevents attackers from successfully forking tokens, significantly strengthening the application's authentication integrity.
Thank you. So I have identified two vulnerabilities during the assessment. So one is a CSP failure to define directive with no fallbacks, and the other one is X content type option header missing vulnerability. So if I explain the first one, which is a content security policy for error. So when that happens, it is basically a browser-side security feature that restricts what resources can be loaded and executed by the web application. So when the CSP directives are missing or incomplete, the browser has no fallback security policies. So those can be lead to XSS attacks and loading malicious resources from attackers to control the domain. So there is a high impact on that because if it is exploited, attackers can fully control the client-side behavior. So as you can see in the network browser, the CSP policies defaultly set to none. So after fixing it, like, okay, if you can go down. Okay. So to fix it, you have to set the header for the CSP without the default SRC as shown in the code. So after fixing it, it will be secured. So attackers have uh, no, no way to attack it. So that's how I fix it. So if you consider the X content type option header missing error, it is basically a modern browsers try to determine the content type of the resource by MIME sniffing. So if the X content type option header is missing, browsers may interpret non-script files as JavaScript or the other executable types. So this can allow attackers to upload malicious files and trick the browser into executing them. So to fix it, you just have to add a simple line of code like as shown. So then the sniffing will be set to non-sniffing. So the attackers cannot upload the malicious files and trick the browser. So that's how I fix those errors. So thank you, and over to you, Emily.
Thank you very much. So I'll quickly explain two security fixes we implemented in our Novice Code web application. So these two security fixes are both aimed at reducing information leaks and preventing malicious attacks. So the first one will be the severe leaks information via X-powered HTTP response header fields, which is previously in our server includes header called X-powered by in every HTTP response. So this header reveals the backend technology we are using for an example, ExpressJS. So while that might seem harmless, attackers can use it to look up known vulnerabilities specific to that technology. So to prevent that, this type of server fingerprinting, we disable the header in our code with a simple line, which is by using app.disable, and inside the brackets you can put X-powered by. So once it is used, now our server no longer exposes unnecessary information about its technology stack. So the second one will be the CSP wildcard directive, which is we strengthen our content security policy, controls which external resources like scripts or images our site can load in the browser. So before we were using wildcards, which allowed loading resources from anywhere, including potentially malicious sources. So that made us vulnerable to cross-site scripting and data theft. So we fixed it by explicitly allowing only trusted sources using directives like default SRC self, script SRC self, site SRC self, which is using the self word. This means the browser will only load resources from our own domain, blocking any unknown or unsafe ones. Which is, as a summary, we have made our server more secure by hiding technical details that could help attackers and restricting resource loading to trusted sources only. So those are the fixed vulnerabilities I have done. So when it comes to the unfixed vulnerabilities, there were rate limiting, which is a low priority vulnerability, which is no rate limiting implemented on API endpoints. And when it comes to the advanced persistent threats protection, no advanced threat detection or behavioral analysis, which is the reasons we not fix it because requires significant infrastructure investment, cost benefit analysis as well. So when it comes to the best practices implementation, we have used secure development lifecycle, and we have reviewed our code as well in the given process, which is as a mandatory security focused code reviews using automated security scanning in CI/CD pipelines. So we have also used scripts, which is dependency management, such as NPM audit. And we have also done the automation monitoring, which is doing regular security assessment scheduling, automated dependency updates for security patches. And when it comes to the discussion and results, as you can see, these are the vulnerabilities that we have detected from our Novice Code application. And there were 14 total vulnerabilities. And once we have fixed 7 of the vulnerabilities, you can see the vulnerabilities have fixed, and it is minimized up to 7 total vulnerabilities. So that will be a assessment done from this semester. Thank you.